So let's start our first session, Geospatial Intelligence for Sustainable and Resilient Transportation Systems by Ms. Jisha Akkara. Let's introduce our resource person, Ms. Jisha Akkara. Ms. Jisha Akkara is an assistant professor at Jyoti Engineering College, specializing in the areas of road safety, pavement evaluation, and transportation planning. Her research and academic pursuits are dedicated to making significant contributions in these fields. She has authored several research papers in reputed conferences and journals, showcasing her in-depth knowledge and innovative approaches in the field. Additionally, she has guided numerous postgraduate projects, nurturing young minds and fostering their research capabilities. On behalf of everyone present here, I cordially invite Ms. Jisha Akkara to commence today's class. Ma'am, please hand over to you, ma'am.
Okay, thank you, Jisha. Am I audible?
Yes, ma'am. You can continue.
Okay, thank you. Is the screen visible now?
Yes, ma'am.
Okay, good morning all. First of all, I would like to thank you, Sripati Institute of Management Technology, Palakkad, the Department of Civil Engineering, the faculty, HOD Srikant sir and other faculties, for giving an opportunity to be a part of this FTP. A very innovative topic, emerging trends in GIS and artificial intelligence in civil engineering. And myself, Jisha Akkara, Faculty of Department of Civil Engineering of Jyoti Engineering College, Thrissur. And I'll be handling the session, Geospatial Intelligence for Sustainable and Resilient Transportation Systems. First of all, I'll be discussing the introduction and evolution of GIS in transportation, why the GIS matters in transportation. As all we know, GIS is not just a mapping tool or just a Google. It's not like Google Maps. It's a system which is storing, manipulating, and analyzing the data. So essentially, it has three pillars that like data capture, spatial analysis, visualization, and output. Data capture means we'll be storing the data, we'll be collecting the data in many ways. That data will be storing and be analyzing it spatially. Then we'll be getting some reports or charts or some visualization reports using GIS. So it answers what is where it is there, and what if it answers the questions like that. For example, why that road is there, or why that accidents are happens in that particular locations. So what happens if that particular road is closed, or what happens if that particular a detour plan is suggested. So that answers will be getting through the GIS. So it will be integrating the different layers of roads, traffics, land use, terrains, demographic, etc. So the GIS software is used by the main government organizations like NHAI, DMRC, Smart Cities, MORTH, and ISRO, BUVEN. So as the figure shows, that we have different layers like elevations, buildings, roads, boundaries, and some other data like water bodies, traffic volumes, etc. So these all these layers will be merged in the GIS. Will be getting an overlay analysis through GIS. So before going to applications, I'll be discussing the why GIS matters in transportation engineering. As we know, transportation is is of a spatial nature. It contains roads, junctions, some bus stops. It will be having accident locations. The traffic flows will be happening from origin to destinations. So it is of a spatial nature. So we'll be integrating all the data. We'll be combining the traffic volume data, traffic density data, the land use data, then what the population data. We will be integrating all the data in transportation engineering. Then we'll be identifying the required data where the accident happens. Where are the hotspots, major accidents are occurring, where the congestions are occurring, where is the traffic density is more. So we can recognize the different patterns in that through the GIS map. The next one is planning and support. We'll be getting some planning for the decision makers, for the transportation engineers or road safety engineers. Through the GIS analysis, they will be getting the some support to for the long-term plannings. And based upon the GIS data, also the cost-efficient structures or cost-efficient plans can be implemented. So these are all these applications are relevant for or applicable for road transportation engineers or road safety engineers or urban planner developers. Now let's look into the evolution of GIS in transportation. So we can see that the first 3 decades are of low pace and the last 2 decades are explosive. In the first 3 decades, it is emerging as an academic part of the GIS, or the pace of the growth is very slow. But in the last 2 decades, the Google Maps, the AIs, digital twins, then spatial analysis are developing in the last 3 phases. Next, I'll be explaining the core GA's concept of transportation before going into the main analysis. So, when we say we have software GAs, we are just saying that we have installed the GA software or QGA software. But the main components of the GIS are hardware, software, spatial data, methods, peoples, network. All these are connected in the GIS. So the people will be collecting the data. Then the data will be analyzed. The data will be stored. The software is coming as one of the component only. So that when we say we have GIS, GIS is a software part only, but it contains the other parts also, like the skilled persons, the skilled, complex methods, the hardwares. All these are the components of the GIS. Then in transportation, when we collect and analyze that data, we have to explain what is vector data and raster data in transportation. So I'll be briefly explaining about vector data and raster data in transportation field. Then only we can understand the applications of the GIS in transportation. So when we consider the vector data, for example, when we construct a plan of the road network, the best jobs. If you are considering the network analysis, the best jobs will be considered as a point vector. If you are considering the accident analysis, the accident hotspots will be considered as a point vector. Similarly, the roads connecting different places will be considered as line vectors. And traffic zones, a congestion, that may be a congestion zone, or that may be a traffic analysis zone, that will be considered as a polygons. So vector data, we can analyze the data in vector format and raster format also in cases of transportation. In the case of raster data, will be considered as the grids. Each data will be considered as grid. That means as pixels in images. So this raster type of analysis will be considering in land use analysis or dam analysis, will be considering the raster format of the data. Next, I'm going to explain the heart of the our TGS transportation, the network analysis. So in this figure, we can see that the different lines are there, different nodes are there. That different nodes may be some different junctions, or some district centers or town centers, or some capitals. And the lines represent that might be rural roads, or that might be national highways. So the lines indicates roads and the nodes indicate some centers. So in the case of when we consider the different network analysis functions, that may be shortest path. Shortest path means we are using Google Maps. The Google Maps is utilizing the shortest path. When we ask for a shortest route from between some origin to destination, it will be giving the shortest path based upon the Digistrust algorithms. So similarly, we'll be getting the shortest routes. If we are planning a transportation network, we will be getting a shortest path between two nodes or two centers, with that may be in terms of a low cost or low travel time or low distance or low fuel expenses, or even in this later scenario, the carbon emissions also, it will be giving the shortest path. In the case of service area, for example, say, show me the all the places that can be reached within 15 minutes a particular area. So the GIS will be showing all the areas that can be reached from a particular center to within 15 minutes by walking or by bus or by any mode. And it will be showing the closest facilities also, the nearest hospitals or nearest fuel filling stations. It will be showing that closest facility also. Then OD cost matrix, if you are giving some origins and some destinations, it will be giving the traffic volumes or traffic flow between the different the origins and destinations. So if you are saying from the different districts in Kerala, from Thrissur to Trivandrum, Thrissur to Palakkad, if we collect the data and give it as input as in GIS, it will be showing through visualization between the different centers what is the traffic volume or the traffic flow between the origin and destinations. Similarly, route optimization can be also will be getting through GIS. Route optimization means we'll be solving through if we have different routes between, as all we know, in the transportation we have four-stage process. In that, one is the route choice problem. So in route choice problem, for non-transportation engineers also I'll be explaining this one. Route choice means we have one origin and one destination, so we will be having different routes. So which routes will be preferred? So which route will be having shortest distance or shortest travel time or shortest cost? Will also be getting through GIS. So this is an research paper published by Das, Ocha and Kramsapi. The paper titled Road Network Analysis of Guwahati City. So they are analyzing the road network in their published paper, that is an essay index published paper. So in this paper, the yellow lines are indicating the major roads, and the red lines are indicating the minor roads. So this blue line will be indicating the shortest route between this first point and the second point, or for origin and destination. So using GIS, and if we are giving the data regarding road networks, it will be showing the shortest path between different origins and destinations in terms of which factor we are giving. Means it might be in terms of low travel cost or low travel time or travel distance, etc. So this is the key data sources for the transportation GIS. We have different free open source software. So OpenStreetMap. OpenStreetMap is an open source software. It is used in QGIS and Python for academic projects. And we have also ISRO Bhuvan portal. It is a Indian version of Google Earth, which is a free software. Will be getting all the images, road layers, and urban layers for Indian projects. Then we can collect the data using the GPS or GNS surveys. So we can collect the actual coordinates of the bus stops or the accident locations or road geometry or intersections or curves. We can collect the data. Then we have NHI data. In NHI data also, the road geometry or road inventory data is available. Then we can collect for urban land use planning or town planning. We can get the data for the population or land use from the town planning centers. Then using the Sentinel and Landsat data, we'll be getting the free satellite images. But the revisit time will be different for Sentinel and Landsat. In the Sentinel cases, we will be getting the historical data. For example, if you are analyzing the land use pattern, how it changed over the years, or how the forest land cover changed over the years, what are the climate effects. That will be the historical data will be getting the using the Sentinel websites, and using Landsat we'll be getting the dynamic changes. For example, what is the flood effects during this year. So dynamic data will be getting the Landsat data, but the revisit time will be different for the Sentinel and the Landsat. Next, I'll be going to the applications of GIS in road inventory. How can we evaluate the payment conditions, or how can we evaluate, how can we utilize the remote sensing and the drone surveys. So in this case, road network mapping and inventory management, we can enter that data. So this is representing a schematic map of the schematic diagram of the AI generated image for showing how the GIS and different action locations will be shown. For example, if you are giving a road data, or if you're connecting, if you're connecting through points to a line, and if you're representing as a road, it is not just showing a road only. That the data or attributes regarding the roads will also be getting the name of the road, the width of the road, the number of lanes, when the last maintenance was done, what is the failure status of failures in that road section, what is the traffic volume, road density. All these attributes can be entered in this road geometry. Similarly, the payment type, it is a flexible payment or rigid payment. The shoulder is paved or not. What is the shoulder width? Then what is the number of curves in that segment, and what is the type of classification of that road. The road markings are available. What is the pedestrian count in that particular section? What is the traffic density? The traffic volume is the what is the traffic volume, any road congestion is there. All these attributes can be entered in that particular locations. Similarly, the bus stops can be entered, the width of the bus stops, or the bus frequency in that particular bus stops, the number of bus stops waiting, the accessibility time for the passengers. So all these the attributes can be entered in that particular segment. That may be a point segment, or point vector, or line vector, or each one of these vectors will be having some attributes. So the data regarding all the transportation related facilities can be entered in each of the vectors. So this is another paper published by the same author of the Guwahati city. In this one, the edges, that the purple colored lines are shown, the edges, and the green colored, these dots are representing the junctions. And similarly, as we told earlier, the yellow line represents the major roads. So these vectors, the line vector and line vector and point vector, will be having some attributes. As we already discussed, all attributes can be entered in these vectors. The next one is highway alignment and route selection using GIS. The alignment, if you are planning for a new road between two different locations, the alignment also can be planned. So we'll be having different options, will be all different alternatives for that particular nodes. Which alternative can be selected for that particular connecting that particular nodes, which one is better option, which one is having the least economic cost, which will be having the benefit cost ratio, suitable benefit cost ratio. So what are the impacts, environmental impacts on this particular roads. So all this can be visualized at a time in GIS. So we have to no need to analyze the different tables regarding the cost, different table, another table regarding the benefit, and the table regarding the impact assessment. So we can visualize all these data at a time using the overlay method in GIS. So in the if you are for that we have to enter the terrain data, the land use data, similarly the soil data, what is the forest area covered in that area. So we know for before we are starting or we are implementing a project a new project in highway or highway new highway road. We had to get conduct an impact assessment. So that impact assessment we have to collect the what are the impacts on environment. On environment means on soil, on noise, on water, on vegetation, on forest, on human beings. So we have to collect the different data regarding this environment. So all this data will be entered as each layer. So that to analyze the impact on soil, the soil data will be entered each one layer. To impact analysis on water, the data regarding the groundwater, surface water, subsurface water, all the water quality parameters will be entered as attributes in as one layer. Similarly, the rainfall data, the forest data, then if it is an existing road, what will be the traffic volume, existing traffic volume on that particular road. So we can predict what will be the traffic volume if that particular road is widened, or if what will be the traffic volume if a new road is constructed. All this data can be analyzed using the GIS. So in the figure, it is an image shown that we have some origin and destinations which will be showing green and red, and the different alternatives are considered. So we'll be having giving a we have the options to give a restricted zones also. So here it is shown as a forest buffer zone. So in the GS, it will be, if you are giving a constraint as that forest buffer zone, it will be considering the different roads, and it will be giving the better road. So in this figure, it is shown as the blue one is optimal road considering all the parameters that we have given. Next is the how can we evaluate the condition of the pavement. So we have different pavement evaluation methods. So we'll be collecting the data. The data collection methods can be manual or using the modern tools. Anyway, we'll be entering the data. Whatever may be the data collection methods, we will be entering that data in the GIS tool. So the GIS will be we can evaluate which road is having the low failure, or which road is having the high priority of maintenance. So for PWD officers or NHA officers, after giving the input data of the road failures, they can prioritize by giving the visualized report. So when we are presenting before ministry, we can visualize the data instead of giving some tables and some values. If you are giving a visualized data, so visualized data to the ministers or related community, they will be getting a easy visualizable data, which road is of highest priority, which road is having the highest failure, so which is having of lowest priority. So that can be shown easily using the GIS. So in this one, the green one indicates the excellent ones. So using the GIS tools and using GIS different analysis methods, it will be giving the heat maps of the different roads, representing of poor quality to high quality. So in this figure, it is representing the green representing the excellent one. This is an AI tool, generated tool image only, but in the GIS tools, GIS also be getting a heat map, which is of highest quality and which is of and the poor quality. In the accident map heat maps, we can get accident maps also. We'll be getting some heat maps like showing which is of the lowest accident occurring area, which is of highest accident occurring area. So in the payment management system, will be the attributes will be the PCA values, the width of the cracks or length of the cracks, what type of crack is there, when is the last maintenance is done. So all these attributes can be entered in the vector data of the road sections. Next one is for evaluating road conditions. How can we utilize the remote sensing and the drone surveys? So that will be entered as the attributes to the GIS data. So these data will be analyzing what is the road condition. So all these cases, some data we have to collect. In cases we can import the satellite images also. For the in the case of satellite images, the satellite images will be downloaded, then that images will be analyzed. In the earlier case, the data will be entered manually as attributes, then the data will be analyzed. So using the traditional methods or using the modern methods like satellite images or AI, GIS automated images, we can download the data, and the visual visualization or the analysis, spatial analysis or statistical analysis also can be done in this using the GIS tools. The next section will be the discussion regarding the payment evaluations and the condition management is over. Then we will be going to next section, the how the GIS can be applied in traffic engineering and the management. So how we assign the different roles, or how we analyze the different junctions. Similarly, we can in these road sections or from each node from origin to destination, we can analyze how the traffic volume or the traffic flow is also happens. So we can assign the different ADT values or PCU values, peaker values to different road segments or road vectors. Then the flow maps can be as in the traditional methods, we can generate some flow maps also. Then where we can compare what is the pre and post improvements before and after cases. We can also compare the capacity utilization mapping, volume capacity ratio also can be mapped into this one. So level of service analysis can also be done. So we have some HCM standard, highway capacity manual standards, to analyze the level of standards. So based upon that parameters, will be giving that constraints, or will be considering that value parameters. So giving that it is input, we can ask a query like show me all the roads which is having the low level of service, show me all the roads which is having highest level of service. What happens if this particular road is closed and the traffic is diverted into another road. So all these details can be simulated in the GIS, and it can be visualized. Next one is ODN analysis. ODN analysis means origin destination analysis. So in a traffic zones, in a traffic analysis zones, if you are having it may be a corporation area, it may be your state, or it may be the analysis zone between the different metropolitan cities. It may be air traffic or road traffic or flight movements. So if you are given the different origin and destinations in a traffic analysis zones, it will be analyzing what is the origin destination traffic flow between these different nodes or different origins and destinations. So it is an important, it is a significant contribution in our four-stage transportation or travel demand analysis. So in the travel demand analysis, OD analysis is one of the important steps. So in that steps, this if you are adopting the GIS also as a tool, it will be and in the Transcat software, it is a software related to transportation. So in the Transcat software, we have also we can do that. The next one is another application in a traffic management, congestion mapping and signal optimization. So congestion mapping, we are using if you are using the GIS, the congestion, as I told discussed earlier, the congestion zones also can be visualized in GIS. So if we will be giving the road network and will be giving the attributes as the traffic volume, the traffic density, and the road parameters like road width, the number of lanes, and the what is the number of junctions that's on. Then it is whether it is in four-lane intersection, two-lane intersections. So we'll be giving all these parameters as attributes attitudes. Then if you are asking for a particular query, show me how is the traffic volume in this particular area, then what happens if the road network is developed. So all these details can be given, or show me all the roads which is having the low width and the highest traffic volume. So all these data can be will be given from the by the GIS. So congestion heat maps can be prepared using the GIS, and signal optimization also can be given. So by using the satellite images or the drone data, we'll be getting what is the geometry of the intersections, what is the pedestrian cycle demand mapping can be done, what is the how's the condition between between the signals, different it is synchronized signals or coordinated signal. Like we'll be getting status of the signals. Status of the signal means how we are they performing. The performing of the signals is in the expected way of the passengers or the drivers. Whether they have to wait for a long time, or it is a sufficient time for all the passengers. So the performance of signals can be, or the signal timing optimization can be also, but can also be done using the GIS. So we can analyze. It is not as a substitute tool. It is not can be as a it can be used as a complementary tool for the signal optimization. So, similarly, the incident management also can be done in the case of some emergency responses management, emergency vehicle routing plans, or dynamic rescheduling. In that cases also, we can utilize the GIS tools. The next one is GIS integration with the traffic simulation and the demand modeling. As I already discussed, the GIS is not a substitute tool; it is a complementary tool for analyzing the traffic data. So, in the case of four-step demand model integration, as all we know, we have four steps in the travel demand forecasting. The first step is the trip generation. The second step is trip distribution. The third step is mode choice, then traffic assignment. That is, in the trip generation means, if you are considering a traffic zone, it's like Thrissur or Palakkad area, we'll be having the different zones in that particular area. So in the Palakkad area, Palakkad town will be might be one zone, Olakod will be another zone, then Malambada will be another zone. So these each locations will be considered as the different zones. So how the trips are generated, or what is the number of trips generated from each zones. So we have to, when we analyze the traffic demand data or travel demand data, or when we predict the travel demand, first of all we have to get what is the number of trips generated from the each zone. So, what is the number of trips generated from each zone? From Malammada to Palakkad, or Palakkad to Malammada, from Palakkad to Olavakkod, or Palakkad to Pudukkod. That generating data we have to collect. The next step is trip distribution. Distribution means how the trip is distributed. Trip means the trip made by one person. That may be house work trip. That may be education trip, recreation trip, or maybe some religious trip. Any trip made by one person. How that trip is distributed. That means from Palakkad to Pudukkod, or Pudukkod to Malambura, or Malambura to Olavakkod to Palakkad. So Palakkad. So how this data is distributed. That might be the data in the second data we are getting in the second stage of the travel demand forecasting. Then third one is mode choice. Mode choice means how what are the different modes in the transportation. The different modes means, if one person is traveling from Palakkad to Shurnur, what mode of he is used, by train or by car or by two-wheeler or by bus or or it is by KSRTC bus or private bus. So all this data will be have to collect by which mode they will be collecting. The next one is the route choice. which route will be they will be choosing. For if one person is traveling from Palakkad to Thrissur, which route is that route through Vadakkacheri or it is through Shornur? What route is chosen by that particular person? So we'll be collecting all this data, that all this data have to enter, we have enter and analyze to predict the travel demand forecasting. So these are the four important steps in the travel demand forecasting. So all these data will be collected and it can be entered as attributes in again in the GIS. So integrating the different tools in the transportation and the transported softwares and GIS, we can analyze this data and we'll be getting some visualized GIS output maps using the GIS. So as shown in the figure, we'll be using the GIS platform, that may be the open source QGIS or RGIS software. Then we can use the Transcat, and we can use the Vism or Vism softwares for the simulation. So spatial and data analysis will be using the GIS platform, and for the traffic demand analysis or level of service will be using the Transcat softwares. So you comparing both two softwares, will be getting some GIS output maps showing the traffic volume, some level of service, delays, emissions, etc. The next session is I'll be handling the public transport and the urban planning. So this is the first application public transport is public transport route planning and the optimization. So to get some data regarding the accessibility, we can ask as a query to GIS. Show me all the places which will be covering the 15 to 20 minutes travel time from this city center. So it will be showing all the locations. Or show me the location which is not having a public transport facility. Or show me the location which is not having a metro facility. Or show me the location which is not having a separate bicycle lines. So all these public transport aspects can be visualized or can be analyzed from the GA software. So for that, we'll be giving the existing routes or existing network to the GIS maps, and we'll be analyzing separately. So we can analyze after giving the data of the current network. We can analyze what are the different unserviced areas, or which are the underutilized areas of the public transportation. All these data can be analyzed using the GIS tools. So we have to enter the if you are analyzing the bus facility or bus public transport facility is not accessible to some location, if you are getting some query like that, so we'll be giving what are different public transport frequency in that particular route, public transport, what are the what are the accessibility timing for the passengers to access the bus facility in that particular location, whether the bus bays are available, the bus base facilities are sufficient, what is the maximum distance a passenger has to walk to access that bus bay. Then the services of the buses are sufficient. The passengers feels comfort, safety, are they satisfied? So all these details can be entered as attributes to assess the public transport facility in particular route. So similarly, for different analysis, different data can be entered attributes, and based upon our query or based upon our objective, the analysis can be done. The next one is transit accessibility analysis and GIS-based urban transport planning. So accessibility analysis, as we discussed earlier, the accessible area within 15 to 30 minutes from particular locations, that will be shown as an accessibility analysis. So from Palakkad town, or from Shornur town, or from Thrissur town, what are the different show me all the hospitals, or show me all the bus stops which is accessible from within 2 kilometers. So that will be shown. So that is accessibility mapping. Or show me the all the IT sector job locations which will be which is accessible from my house locations. So if you're collecting the data or entered as an attributes, it will be showing or visualizing all these data. Next one is land use transport interaction. So we'll be collecting the land use data. The land use data can be collected again using the satellite images or some using the satellite images available websites. So that can be downloaded from the that land use can be data can be imported in the GA software, and the land use transport interactions can be analyzed. That means we know when the land use changes, the transportation demand also changes. When the transportation demand changes, the land use also changes. So the land use transport is an chicken egg relationship. So when one changes, and another one also changes. So that the land use and transport both are interrelated. When one changes, and then another one also changes. So that changes also can be analyzed using the GIS software. Then smart city planning and non-motorized transportation planning also can be done using the GIS software. We'll be collecting the data from the CCTVs which is installed in our transport routes. Maybe that might be some shops or some house. So we'll be collecting the data, or we can get the data from the cameras installed by all the police officers also. So using some sensors also we can collect the data. So all this collecting this or integrating all these data, we can importing the data, we can analyze how the city plan can be done, or whether we have to provide some separate lines for bicycles, or we have to provide some exclusive bus lines for the buses. So that also planning also can be done. Similarly, the non-motorized planning of non-motorized planning criteria also can be done using the GIS tools. This is a public transport accessibility study done in Ahmedabad by Shah and Adhairu. This is a published paper in Journal of Public Transportation. In that one, they have collected some data of the different zones in their study area. They have finally they have analyzed the which is the pub which is which are it, which areas are of having not facility of which areas of which areas which for which areas the public transport facility is not available. So in this one, they are showing the level of service analysis. Then the level 10 shows the excellent performance, and the blue one indicates the poorest performance. The area with no color showing with that areas are not having the public transport facility. So this type of heat map analysis can be done after giving the data or importing the data. We'll be getting this type of heat map analysis, so we can easily analyze which all areas are not having the public transport facility. Similarly, the different analysis in the based upon our objective, we can do what type of this is in the terms of public transport facility, or we can do like which areas are not having the road network, which areas are not having the bus stores, which areas not having the two lanes. All this type of analysis can be performed using the GIS tool. So this is an image to show how it will be analyze the public transport accessibility. This image is shown for easily understanding the GIS images. So in this one, the green one represents the green area represents 0 to 5 minutes walk area. Then the last red line red borders indicates the 15 to 20 minutes walk area. So similarly, as we shown earlier, this type of analysis will be getting. This is a really published paper in the case of Ahmedabad city, which is showing the public transport accessibility heat map. So we'll be getting the image like this in the GIS tools. The next one is GS for transportation safety. So we can conduct the crash analysis, the road audits, and the black spot treatments using the GS tools. The black spot treatments or hotspot treatments are the we have done that type of analysis in the late GS Saturday era. That is a common one we are doing using the GS, the hotspot analysis or the accident heat map analysis. So in that one, it one is an easy tool to analyze in terms of accidents or in terms of crashes. So we'll be collecting the data like the accident locations from the DCRB or from the official websites. So we'll be entering the accident locations as the data. So that accident location might be intersections or might be blocks or from might be curves. So we'll be entering the accident location, the latitude and longitude of the each locations into the GIS map. Then we'll be giving the attributes also. In the case of mid blocks, we'll be giving the road width, the number of lanes, the condition of the road, whether it was raining at that time, or the vehicles involved at that accidents, the type of accidents happens, that is in head-on collision. All these details will be entered as attributes. And in the case of curves, we'll be entering that is an horizontal curves or vertical curve, or it is an curve with gradient. In the case of intersections, you'll be entering the four-legged intersections or two-legged intersections, the number of lanes. So all the in each case of geometry entity, we'll be entering the attributes of each entity. That data will be entered and analyzed using the GIS tools. So in the case of crash data, also we'll be entering the data like it is a minor data, a minor accident or major accident, or it is in fatal accident, or it is in property accident only. This type of data also will be entered. So it will be that at each after entering the data, it will be analyzing using the statistical tools. What are they based upon the neighborhood analysis? It will be showing which areas of are having the highest accident, which areas are highest accident prone areas, or which are of comfortable safe areas. All these data will be, all these analysis can be getting using the GIS analysis. So crash data mapping, hotspot analysis, the road segment analysis, then what is the contributory factor, which is the factor leading to crashes. So we'll be giving the different the accident data, the road data, the terrain data, then hydrology data, the soil conditions, the pavement conditions. All these data will be entered each layer. Then conducting the overlay analysis, we will be getting which one is the predominant factor leading to crashes or accidents. So that when we getting, then IRAP road safety audit report can be also can be generated using the GIS tools. The before and after impactments, what is the condition before improving that before for example before widening the road, what is the accident statistics for that particular road segment, or what is the accident statistics after the road widening improvement. So the before after studies also can be conducted using the GIS tool. Similarly, the pedestrian risk zones in the highly pedestrian in the areas of highest pedestrian traffic volumes, we can analyze the pedestrian risk zone also. The pedestrian risk safety nowadays is an of highly thinking area by the transportation engineers, because the number of pedestrian accidents are more. Similarly, the two-wheeler accidents are also more. So what all can be done through to reduce that type of crashes. So that is an area which is researched by this transportation engineers. So that type of all type of analysis can be done in the case of GIS tools. The next one, in the first one, we'll be conducting what is the how can be the black spot identification analysis can be done. So first, as I told earlier, they will be collecting the data. The data can be collected from the DCRB. In the case of Kerala State, from the DCRB, if you are giving a particular location, that they'll be giving the data of particular locations and all the details regarding the persons involved, the vehicles involved, the type of accidents, the time of the day, any pedestrians involved, the age of the victims, addresses, all the data will be shared as an Excel by the DCRB authority. So we can easily enter the data as an Excel sheet or CSV files into GIS. In the traditional systems, it was in FAR. We have to collect each data from the first report from the police stations. But nowadays, the data is available in Excel sheets in the TCRB. Similarly, from the most websites also, the data is available. The year-wise data they are giving, the state-wise data, then accident type, gender-based data. Then each data is analyzed in the more websites also. But the main drawback is the GPS coordinates are not available now, available. But the DCRB is making attempts to collect the GPS coordinates of also GPS coordinates of the actual locations also, because the location of the accident is they'll be recording the names of some landmarks in their reports, but the proper locations we can analyze using the lat and launch only. So the GPS coordinate is also important while we analyzing the hotspots or the accident spots. So we'll be geocoding these, all these data will be geocoding in the GIS tool. Then we'll be applying the Canada density estimation methods to identify the clusters of the axis locations. Then we'll be doing the cluster validation also. Then attribute analysis also can be done. We already will be giving the attributes of each axis locations. So based upon that road geometry or land use also, we can analyze the attributes also. Then the prior locations also, the maintenance locations also can be prioritized using the GIS tool. So this is a published paper by Wang and Mena, which is published in Journal of Advanced Transportation. This is an essay paper, index paper. So in this one, the red one indicates the very high accident prone locations, and the blue one indicates the low prone locations, and the peach one indicates the high to low areas. In that locations, the accidents are happening in that range, and gray one representing that is not significant. The gray one representing the not significant accident locations. So we can easily identify which are the clusters, where are the accidents happening as clusters. The hotspots and the accident spots are different. In the hotspot analysis, they will be comparing the accident data with the neighborhoods also, then be giving the clusters of the accidents in the case of hotspot analysis. The next one is GS for the freight and logistics network. The freight and logistic network analysis also can be done using the GIS. For example, we will be giving the freight movement. We'll be having the freight movement from different centers. For example, from Ernakulam port to Mumbai port. So they will be having the data. We'll be having some centers to transport the data, and we'll be having some distribution centers. We'll be having some warehouses. So we can enter what are the different existing warehouses, what are the different distribution centers. So where is the location of the ports? So which will be the easiest way for for transporting the freights from one center to another center. So it is the optimal location of the warehouses that can be planned for as a new one. So all these analysis, all these data can be analyzed using the freight and logistics network planning. The freight flow mapping can be done using the GIS. The logistic hub sitting, that is where new locations can be planned. Then multimodal network analysis. In the new Prime Minister's Gati Shakti movement, they have done this type of integration. They have used all the modes, by road, by rail, by air, all the modes of the transport they have considered. Then be analyzing, there will be they will be strengthening the road, the transport infrastructure using the GS tool. They are using the GS tool. Then last mile connectivity is also an issue. So the last mile connectivity means every persons will be having road accessibility and the mode accessibility. So that we can analyze, for the freight distributors, how each roads can be utilized, which roads are underutilized, so which one is the optimal one. All these queries can be analyzed using the GIS tool. The next one is GIS for transportation asset management. GIS transport asset management is done by the FHWA. It is transportation asset management means it is an strategic and systematic process of operating, maintaining, upgrading, and expanding physical assets throughout their life cycle. It is introduced as a concept in USA when the public asked how the public money is spent to different program. This act, the government performance and result act upon some agencies to analyze this different public transport, public money, how they spend. They will be analyzing. For this analysis, they have implemented a new act, Government Performance Result Act. So in that, as a part of that plan, a transportation asset management concept was introduced. So through that concept, the publics are getting an idea how the different the different infrastructures are utilizing in the public money, how much money is spent in case of each infrastructures. That idea will be getting for the public. So the GIS can be integrated in the transportation asset management also. It can be visualize the asset locations. Where are we having where the NHs are located, where the state highways are located, what is the village road density. So each house is having road accessibility or not. Then what is the road conditions of the each roads. Then all public transports are available in all roads. Any other roads are not having the best facility, or any roads are not having the proper road width. So all these as data will be entered as attributes in the data, entered in the attributes in the GIS tool. So after entering the data and using the GIS tool, we can analyze. For example, show me all the bridges which is having poorest condition in the Palakkad districts or Thrissur districts. All this can be analyzed. So we can analyze all the locations by giving a query in the GIS tool. Similarly, the project different alternatives also can be analyzed. We'll be having different alternatives for different problems. So the different alternatives can be analyzed using the benefit cost ratio, similar ones, we can doing the impact analysis also. So using the GIS tools. So we'll be integrating all the GIS tools with the traffic transportation asset management. So all the data will be available in one umbrella. So we can easily analyze. We will be having we'll be managing the transportation assets. As the word indicates, we'll be managing all the transportation assets in one umbrella, integrating with the GIS. So for the GIS transport asset management, as I told, it is utilized by the concept by the FHWA. So it have 4 pillars: the collection, storage, analysis, and the dissemination. For example, in the case of collection that can be done using the traditional method or the advanced AI methods or satellite image methods. So we can collect the data using the manual survey or GPS enabled surveys or drone surveys or satellite images. Similarly, the collected data can be stored using the traditional methods like paper files or Excel files or cloud storage. In the case of analysis, the collected data will be analyzed using can be manual analysis also can be done, or spatial analysis can be done. Some or predictive methods can also be used. We'll be getting the data in some forms of reports that can be reports like some Word documents, or we'll be getting the visualized reports also. So these four pillars can be done using the traditional methods or the latest modern methods. So this is that transportation asset management. We'll be collecting the data and will be analyzing and will be getting as a report. So we'll be integrating with, all these ones we'll be getting with the GIS tools. So this is the data flow from the collection to dissemination using the GIS at every stage of the its life cycle. In the collection stage, in the storage stage, in the analysis stage, in the report stage, we can use the GIS tool from the collection to dissemination. So this is an this is imaginary one showing the road inventory, road asset inventory. So this one shows the locations of the bridges, shows the allocations of the accident sites, road signs, culverts, the where the road conditions are poor or where the road conditions are good. In this one line indicates the roads. Some road sections are having the green, that one's showing the good PC or good payment condition index. Then the orange one indicates the roads are of PCA, poor PCA, that is road is of bad conditions. It is also showing bridges also. So we will be getting the road asset data from one picture only. So no need of the manual drawing. So no need of the one. We can import from data from the Google Earth. Or ISR Bhuvan portal, so that data can be imported into GIS software. So it can easily geocode all these road as entities. Then each geometric entity, the road curves, the road widths, the number of intersections, all these attributes we can easily analyze using the AI tools also in the GIS software. So that no need of the collecting the data manually, no need of the analyzing data manually. So we'll be getting the reports also very easily in a very during a short time in a impressive way to represent the data. So all this type of data can be entered and managed. That is transportation asset management means. We'll be collecting the data, then all the management also can be done in done. So if we have to just open the window, then we'll be getting all the GIS window, will be getting all the data related to that particular area. All the type of details we'll be getting from one window only. The bridges, culverts, road signs, what is the conditions of straight lines, all the drainage details, all will be getting through one window only. Then the dynamic segmentation and linear reference systems also can be done in GIS. What is a dynamic segmentation? It is storing multiple overlapping data on a single road feature using milepost references. They no need to divide the road into small segments for each data attributes. So if you are giving the GIS the data like for this road segment the speed is 60 km per hour. For another road is 80 km per hour. Another road is 100 km per hour. The traffic volume also different. So I will be giving the pavement condition, the traffic volume, the speed limit, the accident density as shown in figure. It will be ended as a different layers. The pavement condition is one layer. The traffic volume is another layer, the speed limit is another layer, accident density or crash density is another layer. So each layer will be each data will be ended as in each layer. These all layers can be overlaid. Then we will be getting dynamic segmentation by the GA software itself, how we have to segment the each road. As the traditional methods we will be segmenting, will be dividing the road segments from one junction to another junction, then or from one intersection to another intersection, or from one curve to another curve. We'll be dividing, or will be dividing road stretch into different kilometers. The first 1 kilometer, second 1 kilometer, like that only. So we can done the dynamic segmentation also based upon the different data attributes. We can do the dynamic segmentation also based upon the attributes. The next one is GIS for proactive maintenance planning and the fleet management. This is the real world application done by the FHWA. The image are shown for easily understanding how the proactive maintenance and fleet management is done. This is already done in the St. John's country, the Washington state, and Oregon in US. In this one, they are showing the GIS based optimization and road planning in the different districts also. So we'll be getting getting an idea about the assets in the different districts at a glance. So these are different district that may be Thrissur, Palakkad, and Ernakulam and Kozhikode. So we'll be getting the number of assets in the each districts from at a glance. If we're asking for number of bridges, if number of intersections, number of three-legged intersections, the number of cameras placed, or the number of curves, or show me the terrains which is greater than 5% in all the districts. So we will be getting all the data in at a glance from the GIS tool. Then what are the challenges in integrating GIS with transportation asset management? Uh, uh, we have many advantages using the GIS and the transportation asset management, integrating the GIS and the TAM, transportation asset management. But we have some challenges also. Then the first one is GIS is viewed as a planning function, transportation as an engineering one. The interdepartment collaboration, as we know in the Kerala state also we have that problem. The interdepartmental coordination between is very essential for using the GIS tool and the transportation management. We have different public works departments for buildings, roads and highways, bridges, etc. And we have LSTDs also, and we have Kerala Water Authority for pipelines. So we should have a proper coordination between these different departments for the efficient flow of a system. So infrastructure system. The interdepartment coordination is a very important challenge in the case of integrating the GIS and the TOM. Then agents are struggling to show tangible return on investment to justify GIS software license. The QGIS is the open source software, but the paid softwares in the case of QGIS softwares also it gives some functional limitations. The modern to get the modern tools we have to pay for the another GIS tools. So to convince the higher officials on the utilization of this type of GIS, that is an very tedious task for the agencies. If you're utilizing this much money for installing the software, we'll be getting this much can save the money and time for data. We can save we can time for collecting the data. So that convincing part very tedious for the agencies to invest the money on the GIS software. Then data collection cost is also very important. The manual labor is very needed, and the data reliability is also a factor. The enumerators should be very serious about the collecting the data. So the manipulated data will be giving the wrong analysis on the GIS also. So the data collection cost and the reliability is also very important in case of GIS and transportation asset management. Then data standards are also very poor. We have the different countries will be having different data standards. The different countries will be using the different payment evaluation methods. So different machines will be using the different methods will be using, the proper data standards are also lacking in the case of the GA stamp methods. So whether you have to use the following whether PCA method for evaluating the payment, or whether whether we have to using the Merlin equipment for evaluating the payment. So that data standards are not available in the case of evaluating the payments. Similarly, in other cases also, the lack of standards, the standards are lacking to enter the data. So if the different countries or the different states are having a coordination for the data standards, then only we can utilize the GAs and transportation asset management globally. Then GS for public outreach and stakeholder communication. The US state, they have the free mobile apps to get the data to get the road asset management details. So public can access the data regarding where are the potholes are located, where are the nets are located, where the improvements are needed. The public can enter the data also in the with the help of the computer science students or using the AI tools. We can also develop a mobile app for our in the case of our district or Kerala state, where the public can enter the data, each data, whether the potholes are potholes are present. These potholes are we have to take care. When we travel, we are seeing some boards or some trees are placed in the case of potholes. So if another person in the case of the night rides, the passengers might not be seeing that the trees or some plants which are kept on the potholes. So if one person using the Google Maps like, or some mobile apps like this, the publics can enter the data like potholes, or this area is having congestion now. This road is having the traffic block. This in this location the accidents are happened. So all the type of emergency responses, all the incident managements, or all the type of payment evaluation, all the details can be entered by the public only. Then public also can be access that data. So it which will be easy for the road users to travel from one point to another point. The next one is, the last section is GIS for sustainable and the resilient transportation. As my topic indicates, the GIS for now it is an emerging area, the not emerging area, it is an already emerging area, sustainable and the resilient infrastructures. In the case of transportation also, sustainability and resilience are very important aspect that we have to consider. So in that case also, the GIS can be utilized for the for reducing the impacts on the environment or for the sustainability. So the first session is the GIS for the sustainable transport planning. In the case of the GIS can be utilized, not more. I think not much works are done in the using GIS in these areas. So the students can be taken up as projects for this for this one. The works on noise mapping also only done in the case of sustainability area. So in the case of transport and application, the GIS can be utilized for emission mapping, the green corridor and empty design, the EV charging siting, the walkability index mapping, or carbon footprint reductions. All these analysis can be done using the GIS in the case of road networks also. So the road network can be easily mapped using satellite images. Then we can collect the data also regarding the carbon footprint using the manual or modern methods. Then this type of analysis, heat map analysis or visualization analysis can be done based upon the emission density or EV suitability score or walkability index in the case of the sustainability planning also. When we do the emission mapping, what are the different pollutants are emitted in particular node network, that data is available from the pollution testing centers also, not pollution testing centers or pollution boards also. So pollution boards have installed some machines in some areas, so we can collect the data from the pollution boards. They will be giving the pollution data in terms of each each pollutant. So that data can be entered as again ended as attributes, and we can analyze the data using the GIS tool. We can using the Canada distance estimation and the cluster data validation. We will be getting some reports. What is the emission mapping? I mean, emission reports will be getting using the GIS tool. Similarly, the green corridors also can be designed. The walkability index in the case of non-motorized transportation, which is in latest trend, the transportation area, latest aspect in the transportation area, the walkability index also can be shown using the GIS tool, or how the carbon footprint can reduce. So this data I have got from the by the report written by the characters. The next one is GIS for the climate resilient infrastructure. The flood risk mapping can be done as we can see in the last few years we have the flood risk in Kerala state, and the Tamil Nadu state also we have seen. So that flood risk mapping for also can be done in our Jyoti college. Already some students have done from projects in the flood mapping, land use based upon the land use data they have covered, the soil data collected, then hydrology from the hydrology and rainfall data also collected. Then using all these data and as each layers, then they have collected layers, and they conducted the overlay analysis. Then using that overlay analysis, they can predict the flood. If this much of rainfall is coming, if this is the terrain and this is the soil type, if this is the land use, what will be the flood, what will be the water level in that particular area. That type of query that we can give in the GIS software. Then similarly, the landslide vulnerability corridors can be also be identified. So recently we had some landslides in our state. So based on collecting the data, and we will be collecting the data and giving us inputs in the GIS software. We can easily analyze. We will be getting the reports, visualized reports, or we can giving the reports to the minister, our Kerala state officials also, to show the landslide vulnerable areas for disaster as a part of disaster and risk reduction management works. We can give this as a report, submit this as a report to analyze the landslide vulnerable areas. Then disaster risk evaluation, route planning also can be done. The road network resilience index also can be calculated based upon the topological vulnerability. The climate adaptation planning also can be done using the GIS tools. So these all are the some areas that can do some research work or some student project works in the case using the GIS tools. Next one is GIS in environmental impact assessment for the highway projects. In the first slides, I discussed about the environmental impact assessment. We have to analyze the impacts on environment. Environment means it contains, it has different components like air, water, soil, noise, vegetation, human beings, animals, etc. It has different components. So we have to collect the data on each component. We have to enter different layers in GIS, and we have to conduct the overlay analysis. So it is a modern tool used in the case of GIS, in the case of EAA analysis. So this one shows, this figure shows an noise impact analysis. This is an impact image. A work was done by the by Banerjee also in the case of air pollution. That paper is published in EAA. That work is shown in this image. In this image, they have shown the noise impact analysis they have done for a particular city and in their study area. What is the spatial noise impact in 2004, in 2014, and what will be the impact in 2039? So that prediction also can be done. So the brown one or red one indicate the high adverse impact areas. So these all can be visualized using the GIS software. Similarly, the air quality assessment, the habitat analysis, the visual impact assessment, water quality impact again on soil, surface water quality, groundwater quality, subsurface quality. All these type of quality analysis can be visualized using entering the data as different layers, again using the overlay analysis. That is the main advantages of the GS tool, that we can conduct the overlay analysis. Instead of analyzing the different tables, we will be getting the analysis report in single window. Will be getting a report, all the report of the all the analysis based upon the soil, water, noise, all the analysis we can be visualized. So all this analysis can be done as the GIS. This also can be done as a student project for the using the GIS tool. So this is the work done by the work done for the Sikkim Himalayas by Banerjee and Banerjee, Ghosh and Pradhan. They have done for NH31. They have conducted the traffic noise modeling also. Then significant noise noise generating segments were analyzed by them. Then they have predicted the predicted the noise impact also and different segments. This is a published paper by the Banerjee. What are the different emerging trends and technologies in GIS? So we can GIS based transportation. We can utilize the AI and machine learning. We can be integrated with the GIS. The lidar and 3D GIS data also can be integrated. The BIM also can be integrated with the GIS tools. The digital twins also concept also can be utilized in transport. Drone-based GIS service can be imported in transportation. Then autonomous vehicles data that is not available in our state, but globally. In some countries, the autonomous vehicles are already utilizing. So from autonomous vehicles data, we can, if some papers are also published using the autonomous vehicles data. So utilizing that type of data, we can analyze the different traffic scenarios or traffic issues. We can also be analyzed. So from the traditional methods of collecting the data, we have to come to the latest modern methods for collecting the data. So we have to just import the data. We'll be getting the analysis easily in using the GIS. So this is an image showing and road corridor survey using the lidar point survey. Using the lidar, we'll be getting then aerial images. So we'll be getting a 3D corridor survey also. This isn't just a generate image only for showing how the data will be, how the GIS will be giving the data. So using the lidar data or drone surveys, we can analyze that drone surveys using the GIS tool. The GIS, the digital twin concept is transportation is showing in this flow chart. In the physical way, we having the road network, we using the road sensors, or we giving the IoT sensors, or we be having the buses or vehicles. So in the digital twin concept, we'll be having using the GIS as a backbone. We can analyze the data. We can do the simulations using the digital twin concept with integrating with the GIS. And these are some softwares in the which are available for transportation engineers. ArcGIS, QGIS, Transcad, or Python plus GeoPandas. That are programming softwares. Then ArcGIS, in this one, ArcGIS software is a commercial one. It is not, which is not freely, which is not available freely. But QGIS is a free open source software. The Transcad is again a transported software which is available in commercial, which is used for the for-stage travel demand modeling. Then we can utilize the Python or Python for programming also. So a graph is shown here in for comparing all these softwares in case of considering the aspects of ease of use, transport analysis, cost, and community and data handling. So for academic projects and for academic works, we can use the QGIS software, which is a free software, and which combined with the Python programming software, we can do some works. From a research point of view, the RGS software will be more suitable in the case similar transcode software also in the aspect of four step modeling that one will be usable. But for students for academic projects, the QGIS is easily available, which can be easily understood and which can be easily utilized using the Python programming. So integrating with the Python programmings, the student can easily complete the works. The next one is the future scope and career opportunities in GIS transportations. The AI-driven crash prediction models can be generated. The climate resilient highway design using GIS. The GIS-based transport and equity studies can be done. Then EV infrastructure siting and optimization. So the carbon footprint mapping for transportation corridors can be done. Then urban air mobility corridors for GIS corridors can be analyzed using GIS. Then disaster resilient evacuation planning can be done using GIS. Then the pathways are for GIS analyst, the NHA, the state PWD, DMRC, BMRC can be used as GIS tools. For transportation planners, some firms are the smart city SPV consulting firms. For road safety auditors, IRAP and ART certified are can also be used. For data scientists, the GIS for ML roles in mobility startups can be utilized. For research scholars from IITs and NITs can utilize. The environment planners from EAA consultancies, ISROs can be utilized the GIS. The urban mobility consultants from the World Bank, ADB, and JICA can also be utilized. So, for all the researchers or for all the persons from all the sectors can utilize the GIS, combining with the can also utilize GIS in combining with the transportation data for the future of the our safe and sustainable and resilient system. The key takeaways from the session are the GIS is foundational to modern transportation engineering. It unifies spatial and attribute data for the smart decisions. Then network is analysis what makes GIS uniquely powerful, routing, service areas, odometrics, and demand modeling. The road safety and pavement management and areas where GIS delivers immediate, demonstrable, and real-world impacts. GIS is central to sustainable transport, emission mapping, EV setting, NMT design, and walkability analysis. The climate resilience requires GIS, flood risk, landslide vulnerability, evacuation, routing, and resilience indices. The environment impact assessment of highways relies on GIS for noise, air quality, habitat fragmentation analysis, etc. The freight logistics and research methodology are emerging frontiers where GIS competence adds significant values. Okay, thank you all. Thank you for listening to me.
Okay, Miss. Thank you so much for your presentation. We will unmute the participants and they can ask questions now.
Hello, ma'am. Hello. Hello, am I audible?
Yes, sir, you're audible.
Actually, I have a doubt. Uh, we are using RGS and QGS. Hello.
Hello.
Hello, ma'am.
Okay, okay.
Which is most suitable for practical applications, QGS or RGS in transportation engineering?
For transportation engineering, the better one is Transcad one in the aspect of for-state travel demand modeling. But in the student perspective, in the economical point of view, the QGIS is the one. But for more, if you want more functions for more analysis, we can use the RGS tools. But that one is commercially that one is available in commercial only.
Ah,
QGIS is free one, free open source software. Then
yeah.
students can easily work on the QGIS software because uh, uh, lots of YouTube videos and YouTube tutorials are available for QGIS also.
Okay. Okay, ma'am.
Okay, thank you.
Any other questions? Ma'am, I think there is no any questions. So now I
Okay.
invite Srikanth sir, HOD of Civil Engineering Department for vote of thanks.
Thank you, Disha. So let me thank the speaker of the day. Thank you, ma'am, for a wonderful and informative session on geospatial intelligence for sustainable, resilient transportation system. So your presentation provided a valuable insights on different applications of geospatial data for transportation systems. So you explained the application of GIS in road safety, road condition monitoring, traffic engineering and management, public transport and urban planning, resilient transport, or EIA, etc. On behalf of Department of Civil Engineering, Sripati Institute of Management and Technology, Vavanur, I extend our sincere gratitude to Ms. Disha Akira ma'am for delivering an insightful and highly informative session. Thank you, ma'am.
Okay, thank you. Thank you for giving the opportunities. Thank you. Thank you, all the members of the Sripati Institute.
Thank you very much.
Thank you all. Feedback form will be provided in the chat session and also in the WhatsApp group. Please complete it for your attendance and certificate. Next session will commence on 2 p.m. Participants, please join at the same time and the same link. Thank you all.